Okay, so this problem here gives us two functions, and they tell us that f is the inverse of g and g is the inverse of f. And what we're asked to do is to prove that they're the inverse. So to prove that they're inverse, you have to show that f of g of x equals x and g of f of x equals x. So I'm going to do the first one, this one first, to prove that f of g of x equals x. So the way I write this is I'll say f of g of x equals, and f is this function right here. So what I'm going to do is I'm going to write this, but everywhere there's an x, I'm going to put a parentheses. And there's lots of different ways you can do this. You can just plug in the g of x first and go, start doing it that way. Or I like to do this way where I show the template of f of x, and then everything that's here, I'm going to put inside here. So I'm just going to write g of x here and g of x here. All right? This is just one way to do it. This way might make it a little bit clearer what's going on. So now that I have that in there, what is g of x? Well, g of x is this function here. So that's this part. And then this part here is the same thing, 2x plus 3 divided by x minus 1 minus 2. Okay. Now, I see that I have two fractions here because 3 is really just 3 over 1. And to add fractions, I need a common denominator. My goal is to simplify, reduce, do all my algebra manipulation to try and get to just x. So that's why I see that I have two fractions. I need to add these together, hoping that I can get some cancellations to happen. So the common denominator is x minus 1. So this is 2x plus 3 divided by x minus 1. Over here, I need to multiply by x minus 1 over x minus 1, which will give me this. Do the same thing on the denominator. Okay. Now, since we have a common denominator, I can go ahead and add the tops. And while I'm doing that, I'm going to distribute the 3 through. So this is 2x plus 3 plus 3x minus 3. All that over my common denominator. Do the same thing on the bottom. 2x plus 3 minus 2x plus 2. I distribute the negative 2 through. And that's over the common denominator. Now I'm going to combine like terms. And what do we do when we divide a fraction by a fraction? We invert and multiply. So this 2x and this 2x give me 5x. Plus 3 minus 3 is 0, so that goes away. And I have x minus 1 in the denominator. Times, I invert this fraction, so this is x minus 1 on top. 2x minus 2x is 0. 3 plus 2 is 5. These cancel. The 5 cancel, and I'm left with x. So now I've proved that f of g of x equals x. So right here, I'm going to have enough room. I'm going to show the other way, that g of f of x equals x. I have plenty enough room here. I wrote all the steps out here. I'm going to show you how you could do some of the steps in your head. So we want to prove that g of f of x is the inverse. So I'm going to write g of x, which is 2 parentheses plus 3 divided by parentheses minus 1. So I'll put f of x in there. Now, f of x is x plus 3 divided by x minus 2. So this is 2 times x plus 3, x minus 2, plus 3 divided by x plus 3, x minus 2, minus 1. Okay? I'm going to distribute the 2 through, and I'm going to multiply by my common denominator. So this is actually 2x plus 6 plus 3x minus 6. 3 times x is 3x. 3 times negative 2 is negative 6. All that over my common denominator. Do the same thing on the bottom. Minus negative 1 times x is minus x. Negative 1 times negative 2 is plus 2 divided by my common denominator. When I divide by a fraction by fraction, I invert multiply. That's going to cause the denominators to go away. Flips it over, those cancel out. Combine my like terms. Those go to 0. 2x plus 3x is 5x. 3 and 2 is 5. X minus x is 0, so this is 5 on the denominator. Those go away, I get x. So g of f of x equals x. So we've proven that f of g of x equals x and g of f of x equals x. So that means that f is the inverse of g and g is the inverse of f.